Hello guys and welcome to a new tutorial. This tutorial will be beginners in Houdini or Houdini for beginners and we will talk about VOPS today. Before we will start, quick announcement, my macro environment design course is now on Gumroad for a limited time for $30. And if you want to check out my work, if you want to get in touch, the website is linked below. Also, I'm currently working on a new website, so hopefully that website will be available soon. And for my Patreons, releasing it next week. Growth in Houdini, and yeah, that exclusive tutorial will be released next week. Okay, so let's close that. Let's have a look here. Okay, perfect. We will talk about VOPS today. So basically VOPS are visual coding, and I will just talk about the basics, how you can set basic effects up on geometry manipulation, etc. So we are here in Houdini. I'm currently on version 19.0561. And let's get started. So first of all, we will need to place down a geometry container. You can do that with hit tab and then type simply geometry and place that down. We will call that, let's call it just geo_VOPS, and dive inside with double click, or you can also dive inside with I and dive up with the U key. So I dive in and you dive up, or just double click, and you can also click here the little arrow here, and you can also click Alt right arrow to dive in and Alt left arrow to dive up. Okay, now let's dive inside and let's start with a really simple, really basic manipulation. We'll place a sphere down for that. So just hit tab again and place a sphere here. I will convert that to a polygon and resolution of 15, let's go to, I don't know, 25 for example. And what I want to do, I want to place down a null, and that null will be our in VOPS. With that, we can place now a different VOP. So there are a variety of VOP nodes. There is the attribute VOP node, the point VOP, the primitive VOP, the vertex VOP. Basically, you can place down an attribute VOP and switch out run over primitive points, vertices, numbers in that drop down menu here. But you can of course also place the desired VOP down. So if you want to run over primitive, you can directly place down the primitive VOP. If you want to run, for example, over vertex, you can directly place down the vertex VOP. But let's just get the attribute VOP here, and its default operation is run over points, and we want that. That's cool. We can rename that, for example, VOP test or beginners, and we can dive inside here. So double click, and now you will see those two, maybe when you first start Houdini, overwhelming nodes here, but they are pretty simple. This is basically your input here. That's your input, and that's your output. For example, if we place the position or get the position input and put that out to the position, nothing will happen. But if you place down, for example, an add node, so we will add something to the position, and place down a constant value and go from float to free float vector, connect that, and now increase the Y value, we can see we can move our sphere basically up and down. So we now basically created a custom transform node for transforming or moving our sphere in different axes. That's, for example, like the most simple operation. Other operation would be if you want to have gradients. That's, for example, pretty helpful. We will toggle that in a second. But what I want to do now, I want to give the sphere some three-dimensional noise, basically. When you press tab and type in noise, you will get different noises. You will get cellular noise, coal noise, flow noise, parodic, pyro, turbulent, unified, Voronoi, Worley, anti-aliased, and so on and so on. You can play with them around, but for now, let's just grab the anti-aliased noise here. And I want to also grab the unified noise static. And now let's play with those noises here. When we, for example, when you get the position and import the position to the anti-aliased noise and export, currently you can see it down here, a float noise. So this is currently a one-dimensional noise. So it's basically one float value. When you pipe that out to the color, for example, you can see the noise will be represented as a color attribute on your sphere. Now, when we go to our geometry spreadsheet and have a look at the color, it's currently ranging from, for example, minus 0.26 to 0.25. When you got negative and positive values. When you click the little question mark, basically the help menu, and look at the anti-aliased noise, it's basically a range from minus 0.5 to 0.5. So you can fit that, for example. For example, fit range. The source min will be minus 0.5 and source max will be 0.5. Pipe that in the color, for example, or let's make a more advanced step and bind export that out as an attribute. For example, my underscore attrib. And now let's have a look at my attrib. When we look at that attribute, you can see here we can now basically remap our anti-aliased noise here. And we can, for example, pipe that out to the color. So what we can do with that. First of all, let's get a little bit more resolution here. For example, 75 frequency. So for example, now 100,000 polygons. We can, or our initial intention was to build up a three-dimensional sphere with noise. We can do that with placing down the displace along normal. So we will displace our polygons basically along the normals. So we'll first need the position. Then we will need an amount. We can use our noise for that. And a specific scale. That scale is currently on 1, and let's pipe that out to position. And now you can see we successfully displaced our sphere. Let me get a sip of tea here, and let me look at the time. Okay. So we now successfully displaced our sphere here. Looks yeah, pretty okay-ish, but let's go for a three-dimensional noise here. And what we then can, for example, also do is just to add that three-dimensional noise to our sphere. And you will get, for example, something like that. So there are several, of course, in every setup you deal with Houdini, there are several ways to achieve the same goal. And for example, you can also use an add node. You can also use like a multiply node, so you can try that out. So there are different ways to create, for example, abstract geometry. For example, like that. Of course, you cannot use that in that kind of state. But what you could do if you want to remesh that in a okayish mesh, for example, what you could do, you could drop down a VDB from polygons and convert that whole thing back into polygons. So for example 0.001, so a good amount of resolution, and maybe smooth it out in the process. And now you have a geometry like that. So that's one way, for example. Let's delete that and that and that, and let's go back to the displace. And let's go back here to 1D noise. And let's pipe that in the amount and back in here. So with the fit range, what we can do, we can again minus 0.1 to 0.1. And now, for example, we can go from -1 to 1, or we can clip the negative value to, for example, 0.31. Let's do from 0 to 1, and let's increase a little bit the amplitude here, for example 2. And I told you about ramps. So what we can do, what is also pretty cool, I think, and pretty useful. What we can do, we got our sphere here, and this sphere got you can calculate the bounding box, and with that bounding box you can, for example, control the displacement. So what we want to do is bounding box, relative to bounding box, file will be input 1, and the position to the position, and now vector to float. And now you will transform the vector into x, y, z floats. And for example, we can pipe the y vector into scale. And now you could see we can we scaled basically it down, and we can also place a ramp here, a spline ramp, and play with that. So now you can see we can manipulate our noise here. Let's give that a B-spline fall off. We can manipulate our noise here, and we can then of course also animate that, for example. And we can do something like that. So we will you can go negative here, and you can quickly create nice shapes with that. Let's go to 0.5 here, and let's go to 1, and let's clip that to 0 and move it maybe inwards a little bit. Now what you could do, is let's go for the ramp here and place down a mix. And what you can do, you can mix, for example, two gradients. So when we pipe them out to the color, you can see this is like from 0 to 1. This will be the z-axis, the y-axis 0 to 1, and the x-axis 0 to 1. And for example, what we could do, we can mix here between, so we can basically blend between two axes here, or we can blend between two noises. So let's just do that. Let's quickly delete them here. And we got our amount here. And now we want to blend between the amount, for example. So let's introduce a second noise. Position to position on the unify static. And let's just view the color for a moment. Let's go with Perlin noise. Let's pipe up the frequency a little bit. And let's pipe that into amount here and that into position. So now we got a beautiful Perlin noise here. You can, for example, turn on a fractal type and get an extra detail layer. You can play with standard, that's FBM, yes, terrain or hybrid terrain, and then you can play with the roughness. Of course, for like a higher roughness value, you need to get more polygons here to represent additional detail. Oh yeah, 2. Let's go back to, I don't know, maybe 100. And for example, let's go to none, and we've got that noise, and we've got our anti-alias noise here. Let's do another thing. Let's pipe that in here and that in here, so we will get a noise in a noise. So we now got basically a dual noise, and you can come up with really nice patterns. So we got a dual noise here, and we've got our Perlin noise. And now let's get the mix here. Whoops, the mix. And now we can blend between the noise here. So now let's promote the parameter up here. And now you can see we can blend between two noises here. The cool thing is with the bias here, the bias you can use to blend, or you can, for example, use another input to blend. Let's go again with the bounding box. Let's get a bounding box here. Let's go for vector to float again. And we want a ramp. On spline and pipe that into the bias. And I want the y-axis. And now you can basically blend between both noises with the ramp here. So that's pretty simple, pretty effective, and you can do cool effects with that. So for example, like maybe like a morphing effect, like a blending effect between two materials. So you can also of course pipe that ramp out then to my attribute here and view that my attribute, and then you can use that for mask in Redshift or Octane, etc., to blend them between two materials. So this is that. Another thing what you can do, what I really like to do, let's do another VOP here. Let's go for 40 noise to introduce another parameter on our noise. And we can do that. Let's get a simple anti-aliased noise setup here. Into amount, into position, that into displacement, and you're basically done. And what you can do now, let's go a vector to a vector 4. So vector to vector 4, into position, that into here, and you will get a 4D noise, and our 4 dimension will be the time, for example. Pipe the time in here. And now you can see we basically manipulate our noise with the time. Of course, maybe that's a little bit too fast in that case. Just drop down, multiply constant, pipe it between here and 1/10 of the offset, etc. will be now, for example, 0.1. And now you can, of course, another thing what you could do is to pipe that scaled value into the frequency. So you will start with a really low frequency and then bump it higher and higher and higher and higher and higher. So you could play with that too. Another thing is you can pipe that, of course, in here again and get like this kind of noise, which is also really cool, but maybe we need a little bit more divisions here. Let's go to smooth shaded. And you could play with that. The cool thing is you can basically amplify that on every geometry. So for example, if you got like a sneaker sole and want to add like a morphing effect, you could use a setup like that. Or if you want a time dependent setup, you could use like that setup here, and then of course implement the real bounding box or another masking attribute from outside and use that. Oh yeah, from outside. Let's talk about that. How to import an attribute. I think that's also important. So let's go for a line here. So we will place down a simple line, nothing fancy, 2 points, 1 primitive. And of course also you could pipe that into here and smooth the whole thing out. Well, I think that's a little bit high for resolution. Oh, that's a little bit low. Let's go for 2.5. And you can pipe that into a VDB, smooth it out if you want to, and cache that out. Okay, enough about that. Now to our line, let's place down a resample node. And with the resample node, we basically resample the line, so to give it more segments here. And let's pipe out the curve view attribute. And the curve view attribute is basically a value between 0 to 1. So you can look that up in your spreadsheet. It's a float value between 0 and 1. And you can, of course, play with that value. Let's place down a VOP again. So an attribute VOP here and dive inside. Let's disable the visualizer down here. And what I want to do now is to bind. So we will import an attribute, the curve view. And now to check if we successfully imported the attribute, you can get the curve view here and bind it out, for example, to color. And now you can see it's black down here going to white. What you can do with that attribute, for example, let's place a unified noise static here. and pipe that out to the color first. And I want to increase here our frequency, and let's go for maybe cellular noise. And I think we need a little bit more resolution here on the line for that kind of thing. Yes, okay. That's looking all right for now. With that, let's place a displace along normal, and we will introduce like a custom normal, so one direction. Let's do it with a constant. Oops, not contour. Constant. Let's pipe that down. Free floats vector. Pipe that into normal. Let's make room here. And let's go for XY. Let's go for Z. And 1. So we will displace in that direction here. And pipe the noise into our amount. And now you can see we maybe need to go down with the noise, maybe 5 by 5 by 5. Of course, you only need to do one axis, but let's go for that. We could also use an anti-alias noise. Yeah, let's use an anti-alias noise for that. Yeah, that's way better, for example. And now we can use the curve view. So we already imported it. Let's manipulate that to spline ramp and pipe the ramp into the scale. And now you will see basically nothing. But let's do one more step before we go one level up. Let's get again the vector 4. The vector 4. So vector to vector 4. Pipe that in here. And I want again the time. And I want to multiply a constant with 0.1, for example. And now dive up. And now we can use the curve view to control that ramp here. So we can have no displacement on the bottom, but I want displacement on the top. So let's introduce a small B-spline here. And what I want to do, I want to multiply that whole scale here with an overall multiplier. So I can have an additional parameter to control the displacement amount. So multiply, let's call that this, let's call that, I don't know, displace. Pipe that in here. Let's make a proper label, of course. We all do that. Multiply displace. Now you can see here our lovely multiplier, and you can now use the multiplier here. And now when we play that, you can see we created that. And of course you can play with the fall off here. You can decrease the amount if you want to. And now you have that swirly line here. What you then can do, for example, copy and transform. You can transform like, I don't know, a few of them, and now you will get something like that. Yes, so I think that's fine for now, for just to give you an overview, and if you want to, I can do, of course, multiple parts with that, how to do, I don't know, way more complex stuff. Dynamic stuff, loop, running VOPS through loops is especially fun. And yes, I hope you liked that, and I will see you in the next one.